everyone, in this video we're going to take a look at some more properties of limits. Here we're going to take a look at the limit of a root and the limit of a fractional power. So the first thing we need to do is we need to remember the relationship between radicals and exponents. So as a reminder, remember if I have something like the square root of x, this is the same as x to the 1/2 power. Now because of this relationship, we can apply a property that we've already seen. We can apply the limit of a power. So we know that the limit as x approaches c of a function raised to an exponent, so if I have f of x raised to an exponent n, this is equivalent to the entire limit raised to that power. So I can write it like this. So now, if I connect this to radicals, instead of having n be a whole number, if n was a fraction, I could still apply this property. So just to show you what I mean here, we'll show it in a couple steps. So let's say I have the limit as x approaches c, and let's say I have the square root of a function. I know that the square root, I can rewrite that as the limit, and I can rewrite the square root as the 1/2 power. And then using our power property that we've already talked about, I can rewrite this as the limit as x approaches c, and then I can put that exponent on this entire thing. And now written like this, I can change it one more time, and instead of having the 1/2 power, I could rewrite this as the square root of the whole thing. The limit as x approaches c of our function, and then the square root of that entire piece. So that relationship between radicals and fractional exponents gives us a new theorem. So our theorem, we have, so the limit as x approaches c, and then I have a function, and I'm taking some root of this function. So square root, nth root, could be anything. This is the same as the nth root of the limit. So now I have the limit of our function f of x, and I'm taking the root of the whole thing. One other piece to this is just to distinguish it a little bit further from our limit of a power property. We do want n to be greater than or equal to 2. So that means we're taking a look at things like square roots, cubed roots, fourth roots, and so on. If n was less than 2, well then we'd just be looking at our normal power property, or we'd be looking at negative exponents, which gets into a little bit of a different territory. Now if I take that power rule, the power property, and I put it together with our new theorem we just wrote down, I can actually get one other theorem that deals with rational exponents. So for example, if I have an exponent, like something raised to the 3/2 power. So I'll just jot that down here. So the limit as x approaches c, and now let's say I have a function raised to a power m over n. Again, whatever that happens to be, 3/2, 9/4, so some rational exponent. And I'm just using the two previous properties we talked about. So now I have the limit of just our function, and then this entire thing is raised to the power. So the rational exponent like that. So again, just two more properties that allow us to work with limits and makes it a little bit easier to evaluate. So let's use these in a couple examples. So my first example that I want to investigate, I have the limit as x approaches 4 of the cubed root of x squared plus 11. So our new property says that this is the same as if I have the limit as x approaches 4. So now instead of having the radical inside the limit, we're going to have the radical on the outside. So I just had the x plus 11, and then it's the cubed root of the entire thing. Now written like this, these are things that we've seen before. We have the limit of something raised to a power. We have the limit of just a constant here. So to evaluate this, I can just use some substitution. So inside the radical, if I substitute in 4, we end up with 4 squared plus 11, and then we take the cubed root of that whole thing. So 4 squared is 16. 16 plus 11, we get 27. And the cubed root of 27, we end up with 3. So just to rewrite this, the limit as x approaches 4 of our radical, this is equal to 3. All right, now for our second one. So our second limit, the limit as x approaches 8 of x plus 1 to the 3/2 power. So this is that rational exponent I was talking about. So again, that property says that this is equivalent to the limit as x approaches 8 of just the x plus 1, and then this whole limit is raised to the 3/2 power. So what that means is now, just on the inside, this is a much simpler limit to look at. So again, here's this is a linear expression. It's a linear function. So to evaluate that, we can just substitute in 8. So we end up with 8 plus 1 to the 3/2. So 8 plus 1 is 9. And then 9 to the 3/2. So a couple different ways we can evaluate this. So one of the ways is, let's just split this up into 2 parts. So remember, this is the same as 9. And then in the exponent, we have 3 times 1/2. So depending on the order you want to go, I'm going to rewrite this as 9 to the 1/2, and then I'm going to put that to the 3rd. Just because it's going to be a little bit easier to take the square root of 9. So here we have the square root of 9 and the square root of 9 cubed. So the square root of 9 is 3, and 3 cubed, we end up with 27. So again, these properties are just a way that we can work with limits, and we can make them a little bit easier to evaluate. And you may be noticing here that a lot of these, it just comes down to substitution. So that value of c, whatever we're approaching, so here we're approaching 4, here we're approaching 8, we end up with the value of our limit. We could get that just by plugging it in. But you do have to know that that's not always going to work. In these cases, it does happen to be that way, but when we examine them a little bit more, it may not always work out that way, and we'll talk about that soon. So, thanks for watching.